Okay, dear students, let's continue again. Here comes now the sixth question. It says, if minus 5 plus 2i is 1 root of the equation x squared plus kx plus m equals 0, you are asked to determine the value of m. Now here, what you need to do is you have to remember, you see, sum and products of roots of a quadratic equation. So recalling that, you can understand, you see, you can come to the solution of this one. Not only this, there is also another important theorem that I would like to state later to answer this one, okay? So here is the solution. So one root of the equation is given, it is minus 5 plus 2i. Now, using conjugate root theorem, as we studied in a classroom, using conjugate root theorem, we see the conjugate of minus 5 plus 2i is minus 5 minus 2i. So if minus 5 plus 2i is the root of a certain polynomial, it is expected to have, okay, minus 5 minus 2i, which actually is the conjugate of it, to be the other roots, because conjugate root theorem says so. So minus 5 minus 2i is also another root of the equation. So using these concepts now, what follows is the product of the roots must be equivalent to c over a. C over a. What is c? C is the constant one, which actually is m, and a is the leading coefficient, which actually is 1. So m over 1 is m. So the product of these two must be equivalent to m. So using these concepts, we can determine what m is going to be. Look, m is going to be the product of these two, minus 5 minus 2i times minus 5 plus 2i. Have you understood the secret behind you, students? The secret is, let me just repeat that. Look, if you are given one of the roots, minus 5 plus 2i, then by default the other root is going to be the conjugate of minus 5 plus 2i. This basically is stated in your, you see, material, and it is under conjugate root theorem. So minus 5 minus 2i is the other, you see, root for this particular quadratic expression. And as we know, in a quadratic equation, the product of the roots is determined by c over a, where c is a constant one and a is a leading coefficient. In our case, our c is m, and the leading coefficient is 1, so m divided by 1. Look over here, m divided by 1 is m. So the product of the roots must make, you see, students, what, student? C over a, which actually is m, okay, which actually is m. What about sum of the roots? Sum of the roots must be minus b over a, students. Minus b is k, minus k over what? 1. So had you been asked to determine the value of k, it's again simple, as you are taking the sum of the two, and finally when you take the negative of the sum, you will obtain the value of k, okay? So in that case you can determine k, but that's not our agenda. Our interest now here is to determine what m is. So we have to consider the product of the two. So we need to apply our distributive property. Negative 5 times negative 5 makes positive 25, and here minus 2 times positive 2 is negative 4, but since we are having I squared, minus 1 turns to be positive 4, so 25 plus 4 makes 29, right, students? And well, let me show you. Negative 5 times negative 5 plus of c makes 25, negative 5 together with 2i makes minus 10i, and minus 2i together with minus 5 makes positive 10i, and minus 2 times positive 2 negative 4, but I times I makes I squared, and as we know, I squared is minus 1 by definition, so minus minus turns that to be positive. Positive 4 can come. So look, student, look, the middle terms can cancel each other, and finally 25 plus 4 can come. So the value for him is 29. Look, so simple, but it needs the concept of those important, you see, theorem together with quadratic, you see, concepts in order to answer this question. What follows from this is next is, you see, the last question, you see, under the fill in the blank item, which says if f of x is given by e to the power of x minus e to the power of x minus x over 2, you are asked to find the inverse of this one, square root of e squared minus 1. So for this, you have to recall the inverse concept of a function, okay? The inverse concept of inverse of a function. And for that, let you see, if f of x is e to the power of x minus e to the power of minus over 2, then to find the f inverse of radical e squared minus 1, you can apply this concept. Let f of x to be y, then automatically from this f inverse y is going to be x, because if f takes x to y, the reverse is done by f inverse, which is to say that f inverse takes y to x, as you see. So in place of y, we will take later e squared minus 1. You see, and now we will try to find what x is going to be, because look, directly substitute y to be radical e squared minus 1, or you see, you can have, if you put radical e squared minus 1 in place of y, this can come. So finding x having y, this is our interest. So let's do that. Let's find what x is going to be. It has been said that f of x is this, so we have assigned that to be y. So this is equivalent to this one because your f of x is this, so this is equated with y. Now let's solve for x, because our interest is to know what x is going to be after substituting y, radical e squared minus 1. So let's solve for x. So e to the power of x minus this is equivalent to e to the power of minus x is 1 over e to the power of x divided by 2 is equal to y. So from this e to the power of x, the whole squared can come, because you can take LCM here. The least common multiple of the denominator here is 1, e to the power of x can come. So e to the power of x times e to the power of x is e to the power of x the whole squared minus this is 1 basically, so you can bring this e to the power of x, you can multiply the whole by e to the power of x, then e to the power of x the whole squared minus ty e to the power of x minus 1 equal to 0 can come. What is this, guys? This is a quadratic expression, quadratic equation in terms of e to the power of x, written in terms of e to the power of x, as you see. You see, e to the power of x, e to the power of x, so it's a quadratic one. As you see, it's a quadratic equation of e to the power of x. So we can now apply a quadratic formula to determine what e to the power of x is. So applying this quadratic formula, dear students, e to the power of x is, as you know, quadratic formula says minus b plus or minus square root of b squared minus 4 over 3. So minus b is, you see, students, minus of 2y, which actually is positive 2y, plus, basically it was plus or minus, but I just skipped the minus 1 because this is always positive. E to the power of x is a positive exponent. E to the power of x is having, you see, a range of positive real numbers. Because of that, we must not consider the minus 1. Have the plus as it is, then 2y plus b squared. It is the square of minus 2y, which makes 4y squared. Negative 4 times a is 1. Negative 4 times 1 times negative 1. Because c is minus 1, positive 4 can come. And this has to be divided by 2. 2a is 1, so 2 comes. So look, students, this is a common 4, so I can take 4 as a common out, and 2 can appear outside. So I can eliminate 2 by 2, again 2 by 2, then what follows? Y plus the square root of y squared plus 1 comes. Mind you, we are looking for what x is going to be here. So to bring this x down, look, this is x down, let's introduce ln both sides. So as I am introducing ln both sides, it will be ln e to the power of x is equal to ln of y plus y squared plus 1 can come. You see, but this x comes down, you see, and this is the same as x is equal to ln of, you see, y plus the square root of y squared plus 1. Our interest was to find what x is going to be once we have square root of e squared minus 1 in place of y. So we can directly put now y to be this expression, the square root of e squared minus 1, and see what x is going to be. Look, take y to be the square root of e squared minus 1. So as you are substituting in x equals ln of y plus the square root of y squared plus 1, what follows is this one. Look, x is the one we have been looking for, so f inverse of y comes. Now this is f inverse. In place of y, I'm just substituting this expression, square root of e squared minus 1, as you see, and this is going to be equivalent to 2. Just put this value, this expression in place of y here, and make it a square, so you are free from radical. Then e squared minus 1 plus 1 can come. You see here, so this is y, it's directly taken as it is, but here y has to be squared, so this has to be squared. As you are squaring this, no more radical, e squared minus 1 plus 1 comes, so minus 1 plus 1 can eliminate each other, so e squared alone can come, and the square root of e squared is e, and thence ln of c square root of e squared minus 1 plus e can come. So our answer is going to be ln of square root of e squared minus 1 plus e.